Hey guys, in this video we're going to be doing something a little bit different from the previous three. So the first three were more focused on, the sine, cosine, tangent functions and kind of their reciprocal versions, those secondary functions, cosecant, secant, and cotangent. In this video we're going to do something that's a little bit simpler, something you've heard of before, and then maybe see how it could work in the context of a trigonometry question. So there's one very famous property and very important property of triangles, that if you have your triangle drawn like this and you've got a right angle over there, let's name this side A, and we'll name this side up here B, and this side over here C. So if you notice, C is the hypotenuse. But we can't really label A or B as opposite or adjacent because I haven't labeled any angles here. And the thing I want to get at in this video is actually has nothing to do with angles. It just has to do with these three sides. Now this is something that you've probably heard of before. It's called the Pythagorean Theorem. Pythagorean Theorem. So this is something you should know because it will be useful to you when we're doing some questions with it. And basically, the theorem states that if you take the length of A, this side right here, and you square it, so you multiply it by itself, and then you add to it the length of B squared, you get the length of C squared. Okay? A squared plus B squared equals C squared. Alright? This is the Pythagorean theorem. So basically you take the length of A and you multiply it by itself, you take the length of B and you multiply it by itself, add those two together, and what you have is C multiplied by itself, C squared. So if you know the lengths of two sides, you don't have to use trigonometry to figure out the third side. You could, but you could just use this property of these lengths. You don't have to use the trigonometric functions that we've talked about in previous videos. Now, what you could do is, if, let's say, you wanted to figure out the value of C, your other way of going about it would be you label this angle theta, you figure out you know B and you know A, so that would be, you don't have to write this down or really remember this, just try to follow what I'm doing. So C is the hypotenuse, right? We know sine theta requires the hypotenuse, so that doesn't help us. We know cosine theta requires the hypotenuse, so that doesn't help us. The only function we could use is tan theta, which is opposite over adjacent. And in this case, with these names, that would mean B over A. Alright, now if we were to do that, we could figure out B over A, so we'd have tan theta is some number. We have to undo the tan function, undo the tangent function. We'd get some value for theta, and then we could use that to figure out the length of the hypotenuse. That's a much more complicated way. If you need to know the lengths of the three sides of the triangle and you have two of them and it's a right triangle, use the Pythagorean theorem. It's the shortest, it's the simplest, and it's very, very useful. Alright, now we're going to do sort of a practice question where you need to use both the trigonometric functions and the Pythagorean theorem. Or you could use both, I suppose. Okay, so let's say I give you, let's say I tell you, we haven't labeled anything, we've just labeled the angle, and I tell you this has a length of 10 centimeters. Okay, and that's all the information I give you. But I also tell you, instead of just theta, I'm telling you theta equals 30 degrees. Okay, this angle in here. So I've told you this is 30 degrees. I've told you that's 10 centimeters, and I'm saying tell me the value of all the angles and the lengths of all the sides. Okay? So in order to do that, there's a couple of ways to go about it. So the first thing we got to do, we know theta equals 30 degrees. From our example in our last class, hopefully you remember that sine of 30 degrees, sine of this specific theta value, is 1/2. Alright? So we know from before, sine of theta, we had something that said sine theta equals 1/2, and then when we ran it backwards to get rid of the sine bit, we figured out that theta was 30 degrees. So I can write it the way I've written it up here. Sine of 30 degrees, is 1/2. Okay, so that's what we've got. Sine of 30 degrees is 1/2, and we also know that sine of any angle is the ratio of the length of the opposite side to the length of the hypotenuse. In other words, the length of the opposite side, for every 1 unit, the hypotenuse has 2 units of length. Okay, so basically this is a fancy way of saying the opposite side is half the length of the hypotenuse. Okay, so now we know sine of 30 degrees is 1/2. So we know that sine of this value is going to be 1/2. So we've got sine of 30 degrees equals 1/2. Now we know the length of the opposite side. We know the length of the opposite side is 10 centimeters. And we need to figure out the length of the hypotenuse. So if you know that the hypotenuse is 2 times bigger than the opposite, then what number is 2 times bigger than 10 centimeters? 20 centimeters. So basically, the other way you could think of it is, if you didn't like that way of going about it, you have 1 over 2, and you know this 10 up on top. So how do you get from 1 to 10? You multiply by 10. How do you get from 2 to your answer? Multiply by 10. 2 times 10 is 20. Okay, so that's how you get it. So you get 10 centimeters and 20 centimeters, and this 20 centimeters is the length of the hypotenuse. So we can write in a 20 right there, 20 centimeters. Okay? Now, going from that, you could do one of two things. You could either use this same thing and use one of the other trigonometric functions, use cosine or tangent, to figure out the length of the adjacent side, or you could use the Pythagorean theorem. Oh, I need that 20 there. Whoops. Okay, now let's first do it with cosine. Alright, so first we'll do it with a trigonometric function. So if we do cosine of 30 degrees, that's going to be, well, cosine of theta is adjacent over hypotenuse. We know the hypotenuse is 20, so cosine of 30 degrees, I'm going to put a theta up here. Cosine of theta is adjacent over hypotenuse. Cosine of 30 degrees is some value adjacent over 20. Okay? So we've got cosine of 30 is something divided by 20. Now, from doing math over the years, I've learned and memorized a few key values, and 30 degrees is one of those values that you should memorize. Okay, so if you're working with if you're working with sine 30, cosine 30, tangent 30, you should know that sine 30 equals a half, and the same for cosine and tangent. And the thing is that cosine of 30 degrees, if I haven't done this wrong, is the square root of 3 divided by 2. Okay, this is the answer. So basically what we have is, we know it was going to be some number over 20, right? This is the adjacent, this is the hypotenuse, but our hypotenuse isn't 2, our hypotenuse is 20. So in other words, this ratio, root 3 over 2, our hypotenuse is 10 times bigger. So we've done 2 times 10 gives us 20, root 3 times 10, you can just write it as 10 times root 3. This must be the length, so here what we've done is we've multiplied this by 10, and this must be the length of our adjacent side. 10 times the square root of 3. Now the square root of 3 is like, what, 1.7 something something? So 10 times that means you have roughly 17 centimeters. This thing down here is about 17 centimeters in length. Okay? That's an approximation. Root 3 is irrational, so it's a number that will never end and never just start repeating. So let's say it's about 17 centimeters, and stop worrying about that there. So we've got cosine of 30 is root 3 over 2, and then we've figured out that if we have root 3 over 2 equals something over 20, then this thing up here must be 10 times root 3, and this is the length of our adjacent side, which is about 17 centimeters. Alright, so we've got 10, 17, and 20. We're almost done. I asked for all the sides, and I asked for all the angles. Alright, we've got all the sides, 10, 17, and 20, and we know 2 of the angles already. We know this one is 90, we know this one is 30. 90 plus 30 is 120, and we know that the total sum of all the angles inside a triangle is 180. So to figure out that last angle up there, all we have to do is take out the 120 that is already accounted for, and we're left with 60 degrees up there. So now, we've got all the sides, 10 centimeters, 17 centimeters, 20 centimeters, and we've got a 60 degree angle, a 30 degree angle, and a 90 degree angle. And you can check to see that you've done it right by making sure that this side is the longest. If this said 17 and this said 20, we've done something backwards, because the hypotenuse must be the longest side of the triangle. Okay, now we've got a few minutes left in this video. What I'm going to do really quickly is I'm going to go through ways that people remember the sine, cosine, and tangent functions. Alright, so there are a couple of acronyms that you can use. The first one, this is the one I learned in school, but it's the one I like less, because it doesn't really make sense outside of the context of math. So this one is SOHCAHTOA. And so basically this is just a 9-letter acronym, and if you remember this acronym and how to pronounce it and all of that, it will tell you what each trigonometric function is. So basically, if you know sine theta equals something, but you can't remember, is it hypotenuse over opposite, or is it adjacent over hypotenuse, and you don't remember, then you can use these to remember it. And so basically the S stands for sine, this C stands for cosine, and this T stands for tangent. O, over here and over here, stands for opposite. A, here and here, stands for adjacent. And H, here and here, stands for hypotenuse. And you can see we've got sine equals opposite over hypotenuse. Right? This is I've written it quite poorly, but you can see sine opposite hypotenuse. We know sine theta equals opposite over hypotenuse. And you can do the same for the other two. We've got cosine adjacent hypotenuse. Cosine of theta equals adjacent over hypotenuse. And then the last one, tangent opposite adjacent. Tan theta equals opposite over adjacent. Okay, so you can pause this and write that down if you wish. I'm going to quickly go and show you a second one. This second one I like better for some reasons and worse for other reasons. I like it better because it makes sense outside of the context of math. Because for this one, this is basically the same as just remembering what each one stands for, because you need to remember this otherwise nonsensical acronym. You need to understand that it's SOH, but if you understand that it's SOH, you might as well just try and remember sine, opposite, and hypotenuse. So it is helpful, it has been helpful to me, but it doesn't make any sense outside of math. So that's where this other one comes in. I don't like this other one as much because it uses names for the lengths of the sides that we haven't used in our classes. And so that can get a little bit confusing. So this is, if you have a triangle like this, you've got your triangle and you've got a right angle, and we're working with our angle theta over here, then here's where the naming gets weird. The hypotenuse is still the hypotenuse, but instead of this being adjacent, we call this the base, and we call this the perpendicular. Okay? Now, I'm going to go through this acronym really quickly. The acronym is some people have, or it's not an acronym, it's just a way of remembering it. Some people have curly brown hair, through proper brushing. Okay, so this is a sentence that makes sense outside of a mathematical context. And if you notice, SCT, we've still got sine, cosine, tangent, and over here you've got P for perpendicular and H for hypotenuse. Sine of theta is that side divided by that side, P over H. People have PH. Same for cosine and for tangent. BH, cosine is base over hypotenuse, and tangent is P over B, perpendicular over base. So I know I went through that a little bit quickly, I just don't want this to go over your time frame, but this is basically the second way to remember it. Both are equally valid. I know last year some of you liked this more than SOHCAHTOA because it makes more sense as a sentence. Just be careful if you're working with an angle over there, like let's say an angle alpha up there, then these names switch and suddenly the base is over there on the side. Alright, so just be careful of that. If you have any questions, let me know. Otherwise, I will see you in the next video.